Hello, and welcome to another lesson. In this lesson, we will be practicing how to go from the names of compounds to their correct formulas, as well as how to go from the formulas of the compounds to their correct names. In the first example, we were given a formula of CCl4 and asked to determine what the name of this compound is. So to do that, we first need to decide, are we dealing with an ionic compound, or are we dealing with a covalent compound? To answer that question, we need to look carefully at what types of elements make up this compound. So we have an element of carbon and an element of chlorine. And we'll notice that both carbon and chlorine are nonmetals. So because this particular compound consists of two nonmetals, this kind of compound must be a covalent compound. Because this is a covalent compound, when we name it, we need to include the appropriate prefixes to indicate how many of that type of element compose that compound's formula, where mono for the first listed element is understood. So we have one carbon, so the first part of the name would just be carbon. And we also have chlorine, but notice we have four chlorines. So the second part of the name will be tetra for four, tetrachloride. In the second example, we're given a formula of CaOH taken twice and asked to determine its proper name. Once again, we need to ask ourselves, is this a covalent compound or ionic compound? The easiest way of doing that is noticing that calcium is a metal, so that means calcium OH taken twice must be the formula of ionic compound. Because it is ionic compound, we do not include the prefixes to indicate how many of each type of element is present. It would just be the name of the cation, calcium, followed by the name of the anion. We would have to notice that OH is one of the polyatomic ions with a formula of OH minus and a name of hydroxide. So putting it all together, the name of the compound with the formula of CaOH taken twice is calcium hydroxide. In the third example, we're given now the name of a particular compound and asked to determine what the formula is. Notice that the second part of this name is acid, which means that this compound is some type of acid. In order to determine the correct formula, though, we need to decide, is this a binary acid or an oxyacid? Binary acids, if you recall, their names always start with hydro. In this example, we do not have the name starting with hydro, so that must mean then that this is an example of an oxyacid. This is an example of an acid that contains an oxygen-containing polyatomic ion. We have to look carefully at the name to decide what type or what polyatomic ion this particular oxyacid contains. Remember that the rules for naming these oxyacids is such that when the suffix is ic acid, as it is in this case, that means that the suffix of the polyatomic ion ended with an ate. So we look at the name of chloric acid. In our minds, we remove the ic part and replace that with an ate. So we're looking for the formula of the polyatomic ion with the name of chlorate. We go then to our list or table of common polyatomic ions, and sure enough, we do find one with the name of chlorate, and it has a formula of ClO3 with a -1 charge. So then the formula of chloric acid will be hydrogen, followed by the formula of that polyatomic ion, which was ClO3 with a -1 charge. Hydrogen has a +1 charge, chlorate has a -1 charge, so it's just a 1-to-1 ratio. In the fourth and final example, we have the name given of iron 3 carbonate and asked to determine the formula of this compound. iron 3 carbonate. Iron is one of those transition metals that can have multiple charges. So we know iron has a symbol of Fe. The 3 indicates that this particular cation has a positive 3 charge to it. Carbonate we'd have to recognize as one of those polyatomic ions. Specifically, carbonate has a formula of CO3 2-. So the compound with the name of iron 3 carbonate consists of iron with positive 3 charges plus carbonate ions, and carbonate ions always have a -2 charge. Then the proper ratio such that the amount of positive charge equals the amount of negative charge we can determine by using the cross method. So this 2 goes in front of the iron, this 3 goes in front of the carbonate to give us a final formula of Fe2 carbonate 3. And we wrap our formula of the polyatomic ion in parentheses, so there's no ambiguity as to how many carbonates are present. Thank you.